Going back to a top story on the launch of supercomputers, Param Rudra by Honorable Prime Minister of India, Honorable Prime Minister Narendra Modi. We're going to talk about the big picture when it comes to how this is going to be a game changer in supercomputing domain in science and technology, but most importantly, the home-driven science and technology, homegrown science and technology. And we're very glad to have a high-powered panel on DD India and in our DD India studio. Welcome Sunita Verma, scientist Group G with a group coordinator. She's also a group coordinator in R&D in Electronics and IT, Ministry of Electronics and IT. Thank you very much, ma'am, for taking out time on the story. And also Dr. Abhilasha Gaur, CEO, Electronics Sector Skills Council of India, India's own supercomputer Param Rudra, launched by Prime Minister Modi. Ma'am, I would like to start with you. So we heard Prime Minister. It was a very powerful speech at the launch where he outlined the broader vision as far as India's science and tech, and particularly the supercomputing domain made in India is concerned. How significant is this going to be for the times to come, and especially putting India on the world map? Because he said that it's not only what we have to, showcase to the world, but we have to do more.
Yes, definitely. So our Honorable Prime Minister's vision is always, bringing in more of Atmanirbharta, or made in India. And we have started with the National Supercomputing Mission, where we are not only looking at design and development, manufacturing of supercomputers in the country, but the complete ecosystem is being developed here in the country, making it truly Atmanirbhar and initiative by the country. Supercomputers, I think, will be are a very important part of our digital India innovation and our research. The research going at the across the country to the maximum of researchers. It is not only being Atmanirbhar, but we are being very cost effective, giving employment, generating employment.
Yes.
There is a network of the supercomputers which have been set up, and this is the first in the series which is totally designed, manufactured and developed in the country by CDAC. CDAC is an R&D organization of our ministry, which was developing Param supercomputers since 1980s, 90s.
Okay.
So now we have
come a very long way.
True. And now we have our own servers, we have our own software stack, we have our own network system, and
so
we have
India is owning it fully.
True. So we have increased the local content way back from 15% to 50% now. And then later on will be going for our own chips, so as to say, our own ASICs, the GPUs, graphic processor units, and our central processing unit, CPUs, which are an integral part of the supercomputer. So that will also be developed and designed in India. So we are going towards that.
Let me take also opening reactions from Dr. Abhilasha Gaur. Ms. Gaur, Dr. Gaur, how do you see this launch, and also in tandem with science for self-reliance as reiterated by Honorable Prime Minister today?
I think it's a day where we all Indians should have proud, and in the evening when Honorable Prime Minister launched this thing, I think we all were very, very happy. And if I talk about the national, this mission, supercomputing mission, it started almost 9 years back in 2015 when Ministry of Electronics and IT with the Department of Science and Technology, they started this in 2015 with the implementation by CDAC Pune and IISc Bangalore also. So what we see is, the series, how India has started working on it around 9 years back, and then what kind of success we see now. And this is, you can see, it's just the starting. There's the baby steps, because right now we are talking about supercomputing, high performance computing, and later on Prime Minister also mentioned that in the days to come about the quantum computing also. So I think we are on the right track. And when we talk that almost 77 years of independence and 2047 we want to be a developed nation once we'll complete 100 years of independence. So I am sure that I'm really happy that research team, all the scientists who have played a very, very key important role in development of the supercomputers and high performance computing systems. So my congratulations to all the team who have worked on it and to all the Indians also.
We have, in fact, one of the representatives of one of the important teams behind this mission, rather. Ma'am, we are given to understand that the significant portions of its components, some portions of the components are manufactured in India or are assembled in India. Going forward, if you could just give us an insight in what all domains, just for a layman to understand, not keeping it very technical, will this technology be of use?
Yes, so if we talk about supercomputers or high computing, it is that it can perform lots of operations, parallel operations, and at a time. So if we have immense data, bigger data, and we want to do real-time compute, so we look at supercomputers. That so if we look at, suppose, weather monitoring is one of the examples. So weather monitoring with a smaller amount of data can give you some precision. But the more the data, the bigger, the better will be the precision, the finer details you can get.
The predictions and analytics
will be more accurate. So with these are some few examples. So, and even in suppose I look at genomic drug discovery. So there are proteins, there are DNAs. So going to that level of research, that looking at each of the protein in the DNA and then looking at the impact of what it will be on the health. So you can even look at precision health or a very personalized health for a person. So if a patient is responding to a certain medicine and what will be the effect. So if you want to get that amount of data and predictions, then there is flood monitoring. So if you have an early detection of flood, so we have some certain I'll say grand challenges or applications that we are looking at. There are 5 of them. So one of them is early prediction of flood. So we are working with Central Water Commission, where we are predicting flood maybe 2 days in advance, where the government and the authorities can plan on how to
advisories.
So send the advisories, send the set up infrastructure.
What about artificial intelligence?
Yes. So
because that's the keyword these days.
So high performance computing also involves a lot of wherever the application is there developed. So AI is an integral part of it to make it more accurate and to make it more detailed. So AI, so we have one Param AI 410 AI petaflop system, which is being used at present for all AI applications by researchers, by startups, by MSMEs, for the AI based application. So AI as well as HPC goes hand in hand. In fact, the systems which Honorable PM has dedicated to so most of them will be for these HPC AI applications.
Okay. Let me take this question to another guest, Dr. Gaur. Dr. Gaur, there was also very significant mention of Young India and how this technology has been dedicated to youth of the country. And if you look at the speech and the PIB release also talks about the humongous amount of skill training as a run-up to this launch, and this is just the beginning. If you could also share some insights.
Yes, some of the key insights, if I tell you, when he started the speech and Honorable PM said that this is innovation ki parampara, what we are starting. And he also said that we are building an ecosystem for semiconductors. And Sunita ma'am comes from Ministry of Electronics and IT. And in December 2021, when Indian Semiconductor Mission was launched, and now we see a lot of announcements which are coming up. Already Tata have announced their fabrication unit in Dholera in Gujarat, CG Power, Micron, and almost 7-8 more companies who have announced right now. So already when we are talking about that India wants to be one of the key partner in the supply chain, not only for India but for the world. So definitely scaling becomes very, very important, because when we are saying that come to India and make in India for the world, So definitely all the companies who are coming to India with the confidence that they'll be getting a good ecosystem. So it's not only about the infrastructure and the government policies or ease of doing business, but human resource is a very, very key factor. That is the reason all these companies are coming to India also. So skilling is definitely plays a very, very important role. And let it be in terms of computing or in terms of semiconductors. So there is a separate ministry also now, which completes 10 years now, that Ministry of Skill Development and Entrepreneurship,
Yes.
which focuses on skilling. And in India, as we say, that we identify 36 sectors where anybody can get employment. So it can be like automobile, it can be aviation, construction, banking, electronics, IT, green jobs. And for each and every these 36 sectors, so government has made a specific sector skill council, so that a focus approach can be there.
Yes.
So right now, like I represent Electronic Sector Skill Council of India. So same way we have 35 more sector skill councils, and we work very closely not only with MSDE but with METI also for various capacity building programs. So definitely one more thing I would like to add, that now a lot of things are coming into, you can say, sync, because earlier the schools, the colleges, the universities, the ITIs, everybody was doing their work, but on a different, you can say, ways. But now a national credit framework has been launched. Now, whichever courses you are doing, so a credit-based system is there, and there is an academic bank of credit. So either you are doing a short-term course also on skilling or upskilling after you're completing your graduation or while pursuing your BTech also. So in your academic bank of credit, in your DigiLocker, all the credits gets in there, and that is how it helps the employer also to take a note. Okay, if somebody is coming, how they'll be more employable. So definitely a lot of work is happening in skilling also. So quantum and supercomputing, HPC, definitely now a lot of work we see that we'll be doing in future also, because it will be generating a lot of jobs in data science, data mining, because once we'll be getting so much of data, so AI, ML, data mining. So these are some of the, you can say, the verticals where we can see a lot of opportunities for the youngsters in the coming years.
Okay. One final question. I'm sorry, we're really running short of time, but I would start with Dr. Gaur. Now, it's also being pitched as one of its kind attempt to boost countries' computing power. How do you decode this? What makes this so super special?
See, super special is when we started with the normal computers and now we talk about supercomputers. So it is, you can say, 1,000 or 10,000 times more fast the calculations will happen. It is not only 0 or 1 or binary form. It is like Sunita ma'am also said that it is the parallel computation which happens. So when we are getting a lot of data in so many fields, let it be biotechnology, let it be, if we are talking about industry 4.0 or manufacturing. So if we'll be able to do this data, and if we'll be able to run a lot of AI and simulations on this data, so definitely the kind of decisions what we'll be able to make, the kind of research it will assist, I think it will have many folds development what we'll be seeing, not only in manufacturing, we'll be seeing the results even in healthcare, medical, even in agriculture, and as the weather forecasting also says. So definitely it's a 360-degree view or impact what the supercomputing will be having on India's development in the coming years.
Yes. Ma'am, your take?
Yeah, so definitely I think the impact will be on all the sectors, because research is important in all the sectors, and supercomputer is something, and AI along with the supercomputers is AI enabled supercomputers are actually used for training, for deep tech research, and also for taking, developing new applications and solutions for the mankind. So for us, it is very important that all the applications that we develop, we have the researchers who have the handy systems and in their and access to that, and we are enabling that through this growth. And I was just giving an example of one NCRA system in Pune, where this will be used for the fast radio burst real-time monitoring and seeing if there are any for pulsars. And this will be one of the, I think, the path breaking or breakthrough research, which will really enable us to look more into the cosmology, into the astrophysics areas. So that, and from there, if you look at agriculture, farmer, so the research, deep tech research, will also enable the farmers to get better quality seeds, look at the weather, get very precision farming. So it is cutting across all the areas, and because of the enablement of our local, or I'll say indigenous supercomputers, along with, I'll say, the manufacturing, I'll emphasize on that. Vividian is our partner, and Keynes is also one of the partners for manufacturing. So having all of it in-house matters a lot. And we are not stopping here. We'll be going together for
upwards and onwards.
Yes,
this
for
is just the beginning.
For more of local content, along with the chips and our own systems.
I think
towards the exascale is what
you know. You talk about the supercomputer, but at the end of it, I think even behind making that supercomputer, it's a super brain of a human being.
Definitely.
And that's the team that has worked under the leadership of Prime Minister Narendra Modi.
Definitely.
Thank you very much, Dr. Abhilasha Gaur, for joining us, and also thank you very much, Sunita Verma ji, for joining us. And Param Rudra, India's clearly supercomputing powerhouse, is there to rule. And both of you explained to us what makes the system an extraordinary computing superpower. Thank you very much. Thank you for joining us. Thanks.